Hello, everyone. My name is Reza Rahman. In my day job, I'm Principal Program Manager for Java on Azure at Microsoft. Today, I'm actually going to talk about more about my Jakarta EE Ambassador hat, if you will. This talk, as you can see, is effective Kubernetes for Jakarta EE and MicroProfile developers. I will explain what this talk is a little bit about and what I'm trying to accomplish in the next 20-25 minutes or so. So the title of the talk is relatively appropriate. So basically, what I'm trying to tell you is what do you need to know as a Jakarta EE and microprofile stack developer to make effective use of Kubernetes? What are the specific things that are nuances for this particular technology stack is what I want to focus on. So I don't have any slides whatsoever for this talk. It's a slide-free talk, and it's 100% actually demos. But hopefully what I aim to give you is something a lot more valuable, and that is basically the repository URL that you see here. So in this repository, what I have is a workshop that shows you how to make use of best use of Kubernetes as a Jakarta EE and microprofile developer. I have done this work. The intent of the workshop and the intent of this material is that it is essentially self-driven. So you can do this by yourself. So I have seen people do this workshop end-to-end by themselves, and I've also run this workshop at conferences before. If you start from scratch, this entire workshop is going to take you just about plus or minus about 6 to 8 hours. So obviously we don't have 6 to 8 hours here. So what do I plan to do? So what I plan to do is give you enough of an introduction into this material and show you just about enough of the basics of Kubernetes and Jakarta EE and MicroProfile so that you can go ahead and take a log on onto this repository a bit later and do the workshop by yourself and understand the basic gist of what is in the workshop. Okay, so with all that, let me explain the structure of the workshop and at a high level what the contents are. So the first bit of content that is in this workshop is just a simple Jakarta EE application. It is very much like what you would be doing in your development environment, or if you didn't have anything to do with the cloud or Kubernetes whatsoever. And that is to get this basic Jakarta EE application set up on your own laptop using, the technologies sets that hopefully tool sets that you've used for a long time now. So once we do that, we basically have a baseline comfort level of the application. And then from then on, that gets us ready to explore different aspects of this application on Kubernetes and actually begin to put this application on Kubernetes. So the next section of the lab is called clustering. And basically what we do here is we take that application and actually run it on Kubernetes and show you the very basic way that you can do that. In this particular section, we use simple Kubernetes primitives like deployments and services and the like. There are obviously more advanced ways of doing that same bit of work. The workshop will cover that as well. But basically, this will tell you the basics of how does these Jakarta EE and microprofile runtimes in general work in a Kubernetes environment, and how do the things like administration, deployment, clustering, and a bit of monitoring work in a Kubernetes environment as opposed to maybe in an on-premise environment. The next section of the lab has to do with how you would do monitoring and observability in a Kubernetes environment. So certainly you can do things the old school way using application server admin consoles. In fact, in the first section, I will show you how to do that. But really on Kubernetes, you want to do a lot more. So for example, Kubernetes, MicroProfile and Jakarta EE, although they don't directly address the Kubernetes space, they do a lot that actually aligns very well. So you want to, on Kubernetes, you want to use things like liveness and health liveness and readiness checks with something like MicroProfile health and MicroProfile metrics. You want to use something like Prometheus and Grafana and use, again, MicroProfile metrics and Jakarta EE REST services as a way to do that. And basically, this particular section will show you how to do that in a more or less generic fashion. The next section talks about operators. Most of the Jakarta EE runtimes have aligned themselves with the Kubernetes space by providing certainly the basics like providing Docker images and the like, but more importantly, providing Kubernetes operators. And you'll see for yourself when you're going through the workshop what the difference is between just using Kubernetes primitives versus using operators. The operators provide two things. One, they provide a higher level of abstraction, so the syntax is a lot more natural and a lot more compact. Basically, it's sort of like a DSL for that particular app, using that particular app server on Kubernetes. The other thing that operators do is that they take control of certain aspects of the Kubernetes deployment. So, for example, the deployment, cluster deployment actually happens through the operator as opposed to using Kubernetes services. And in general, the app server runtime is more aware of Kubernetes, so it can do in a more app server native way, handle things like reliability, monitoring, distributed tracing, and the like. The final section of the workshop deals with CI/CD pipelines and essentially DevOps. So basically what we do here is show you how all of this stuff that you have been doing in the past, how that changes when you're using Docker and Kubernetes with Jakarta EE and MicroProfile in a DevOps toolchain. The example that is in the workshop is GitHub Actions. You can easily use something like Jenkins if you like. But the basic objective is showing you the differential of how things are done using Jakarta EE and Kubernetes as opposed to doing it, for example, the thin war way. So okay, so without further ado, let's jump into the application and show you just enough so that you know what this workshop is really all about. So in the Jakarta EE folder, there's basically step-by-step instructions on how to get this basic Jakarta EE and MicroProfile application set up in your laptop environment. Obviously, to save time, I've done a lot of this stuff by myself ahead of time already. So this is nothing. The application itself is not too fancy. It's just using a normal Jakarta EE stack, stuff that you are probably already used to, like Jakarta REST, Enterprise Beans or EJB, CDI, JPA or persistence, JSF, bean validation, and the like. So in terms of the setup, I've already set up JDK 11. I'm using Eclipse Temurin, but you can use whatever JDK 11 runtime that you like. I'm going to use Eclipse IDE here for my example. You can use any Maven capable IDE. In the end, the application is just a Maven-based application. We will be using Docker for the database portion. You don't really need to use Docker, but it's a bit handier. So you'll see that in action in a moment, and you need this code base in your file system, which I've already downloaded as well. So first thing is, it's a CRUD application. It's using a database, so we need a database. I could, have installed Postgres, which is the database I chose to use natively, but there's really no reason to. I'll be using Docker in a moment with Kubernetes anyway. Might as well use Docker to just get the database up and running as well. So I don't really need to install Postgres natively. I can just use a Docker command to do that. So I'll show you how to do that. I'll explain the syntax a bit as well. All right. So the syntax here is Docker run. So run the Docker image. The final parameter is Postgres. So basically that is saying take the Postgres image that is publicly available and run it locally. Don't do a native install is not needed. I'm also saying that I want to run this and be accessible on port 5432, and I want to use a local file storage for this. Okay, so I'm running the database. All right, so the database is up and running. This is pretty quick because I've already run this earlier in the morning. So everything is really just cache, and it's just running from the cache. So now let's go ahead and take a look at the application. I've already set up the application. So if you go back to the instructions, the rest of these instructions will tell you how to set up Eclipse, how to set up the application on Eclipse, how to set up OpenLiberty, which is a runtime I happen to be using. You can use any Jakarta EE runtime, really. More or less everything that we say is applicable to most of the Jakarta EE runtimes. But in this case, I'm choosing to use IBM Webster Liberty for my demo. So this will also tell you how to go get that set up on your Eclipse environment. So here's my Eclipse environment. I already have the application set up. It's just a Maven-based application. It's a very, very simple POM XML. There's really nothing to it. You can see how small my dependency chain really is. It's just I'm depending on Jakarta EE more or less, and I have JAX-B because I'm using Java 11, so I need the additional runtime in place there. But other than that, very straightforward stuff. As you can probably also see, I have Liberty up and running and set up on my machine here. So I'm going to just do a Maven clean build, and I'm going to just build my WAR file, and deploy that WAR file onto my Liberty runtime, which I've already configured using my steps that I have outlined in the workshop. So let me do a Maven clean. Okay, clean is successful. Do a Maven install here real quick, which is just going to build my WAR file. All right, so my WAR file is built. If I scroll over here, you will see that here's my WAR file that was out in the target directory already. And then I'm going to just run this via Open Liberty. So I'm just going to run as and say run on server. It's going to make me choose Liberty. Yes, I want Liberty for this application. And then just hit finish, and Liberty should start up here shortly. Okay, so the application is up there. So let's open up a browser and take a look at the application real quick. And here we go. So there's Liberty up and running. And now let's take a look at the application itself also. So here's the application. It's just a simple CRUD application. Let me just delete this entry for you so you can take a look at it. I'll create another one. So there you have it. There is a REST endpoint behind this. So there's the REST endpoint if you are curious to take a look at that. That's about it in terms of the application. I think I can actually shut down the server now, and I could even probably just close Eclipse. Also, I don't really need it. Actually, we'll just leave it up and running. It doesn't matter that much. So now let's move on into the cloud environment. So we do have the application up and running locally now. So let's go ahead and try to put this application up in the cloud using Kubernetes. So here is the instructions on how to do that. In my case, I'm using Azure, but I think of Kubernetes actually sort of a Java EE for the cloud. So it shouldn't really matter that much what cloud implementation you use, as long as you're running some kind of Kubernetes runtime. In this case, though, like I said, I am using Azure. Okay, so you will need a database, just like we have a database locally. In fact, let me go shut down the database because I don't need it anymore. You will need a database on the cloud. In order to save time, I've already created the resource on Azure. So this is using the Azure PaaS for Postgres. I don't know if you can quite see the small font here. I think, let me see if I can increase the font just a tiny bit. Oh, that's too bad. Okay, that's not going to work. So I do have Postgres running. So this is accessible on the cloud. I can even access it locally if I so wish. And I do have a Kubernetes cluster already up and running as well, again, following my instructions. So this saves me quite a bit of time in order for me to be able to do the demo for you. So there's the instructions on how to set up Postgres. There's the instructions on how to set up Kubernetes. I will be doing the deployment through the kubectl tool, a command line tool locally. So in order to do that, kubectl needs to be aware of the remote Kubernetes cluster. And this is a command that will help you do that. I've already done this command. I can show you that, in fact, I am talking to Kubernetes. So I can do a kubectl get nodes. Okay, so you can see that I have a single node up and running. I can do services. Right, and you can see the only service that is running is Kubernetes itself. We can do finally pods, and you'll see that I don't have any pods. So it's a fresh cluster. There's nothing deployed to it whatsoever at this point. So next thing you need to do is you do need to configure an ingress. The reason for this is that the application I'm using is actually a stateful application. It's not a stateless application. So it needs sticky sessions. And the default load balancer in most Kubernetes clusters, if you just deploy a service, it does not include features like sticky sessions. So in this case, I'm going to just use Nginx as my Ingress controller, and I actually have already set this up. There's several steps you need to do in order to do that. So you set up a namespace, which I've created already. You deploy Nginx using Helm, which is another tool for Kubernetes, and then you finally install the instance of an Ingress controller. What I'm going to do now is actually just show you that the Ingress controller is up and running and show you the IP address of the Ingress controller as well. All right, so there's my Ingress controller up and running. As you can see, there's a load balancer instance. And as you can see, it has an external IP address. This is the IP address we'll be accessing the application with. There is no application as of yet. As soon as I get the application up and running, you will see that you can access it through the Ingress controller. Just for fun, take a look. Let's take a look at what's in the Ingress right at this moment. Oh, I think I have it cached. So it's 404 not found. That is correct. There is no application that behind the Ingress controller at the moment. So the Ingress controller will simply just tell you, hey, I have a 404. All right. So next, we're going to deploy this application. So remember that I've already built the WAR file. So I'm going to just, next thing I need to do is actually Dockerize this WAR file and deploy it. So let's go back to where my WAR file was. So it's in this Jakarta EE Cafe target directory. And here's my WAR file. All right, and we're going to go into the clustering directory, and I'm going to just paste it here. All right, now I'm ready to build my Docker image. So let's go ahead and begin to do that. So I will be pushing this Docker image onto my Docker Hub account. So just to show you, this is my Docker Hub account. There's nothing, says there are no repositories in this namespace. So it's clean. There's nothing on there. So the first step is for me to actually build the Docker image. So let me just copy the command on how to do that. And I'll also show you the contents of the Docker file. Okay, so show you the command and also the syntax. All right, so Rezaraman is the name of my Docker Hub account. Because I'll be uploading it to Docker Hub, this prefix part needs to match whatever I have in my Docker Hub account. Other than that, the command is simply docker build and whatever tag you want to give it. In this case, the tag I'm giving it is Jakarta EE Cafe V1, version 1 of this application. And the dot is saying, take a look at the current directory. And in the current directory, there should be a Docker file that describes how you build this Docker image. So let me go ahead and press enter. All right, so the build is oh, no, I'm not in the correct directory. My apologies. So I'm going to go into the clustering directory. All right, reissue that command. So the Docker file should be here. All right, so the Docker file is done. The Docker image is now built. I'm going to show you the contents of the Docker file really very, very quickly. All right, so I'm starting with Open Liberty. As you can see here, let me increase the font size just a tad more. Okay, I'm beginning from Open Liberty, copying the Postgres jar file, which I need to connect up to the Postgres database. I'm copying it to the server.xml. You can take a look at it after the fact. Really, the only thing significant there is just the database configuration, as well as I'm copying over the WAR file, and that's about it. So my Docker image is now built. Next thing I'm going to do is I'm going to push this Docker image onto my Docker Hub repo. So again, I'll copy the command for this and I'll explain the syntax. So remember that I already have the Docker image built locally. Now I'm going to simply push this Docker image to my Docker Hub repo so that I can access it from Azure and the Kubernetes cluster can access it. And this should be, I hope, relatively quick because I just did it earlier this morning. So this should finish in not too long of a time. Okay, and as we all know, when you're doing live demos, things don't go as you would expect them. So I do hope this upload is going to finish soon. Not yet, still going. All right, that should be done now. So let's take a look at that. All right, so now I do have the Jakarta EE Cafe image up in my Docker Hub. Next thing we're going to do is actually do the deployment. Okay, so I'll do the deployment first, and then I'll explain to you what the deployment descriptor looks like for this deployment. So I'm going to just go and head here. I'm in the right directory. Let me double check. Yes, I am. And there's my deployment descriptor. I'm going to just issue this deployment descriptor. All right, and the deployment looks to be done, but let's confirm. So now we're going to do get pods with a watch flag. All right, actually, it's already up and running. That was pretty quick. Let's do services real quick just to make sure, and we should be able to see a cluster IP service deployed. All right, so as you can see, there's Kubernetes, but now there's a cluster IP service as well. So now we should be able to access our endpoint and be able to see the application up and running. Not quite yet. It's still deploying. Okay, I'm going to just make sure that I get a fresh instance of the Ingress. All right, and there we have Liberty up and running. Sometimes it just takes just a moment and things are just a little bit in the cache. So let's go ahead and access the Jakarta EE Cafe application. So there's the application once again. The other thing I'm going to do is also show you that the admin console, you can access the admin console here as well. So let's go ahead and do that. Okay, I'm going to just create a fresh incognito window here. All right, so there's the application server console, which you can also access because it is up and running, and I've deployed it as part of my deployment. I've enabled the admin server console, so you could do some basic monitoring of your instances. So let's hit explore here. And if you go into monitor, for example, it should populate some useful information here in just a moment. Yeah, so there we have it. There's some CPU information, there's some JVM threads and heap memory and loaded classes and the like. So some bit of information that you can see from the deployment. Okay, shut that off. And that's really about it in terms of getting a basic Kubernetes application up and run, a Jakarta application running on Kubernetes. So as you can see, basically using the Kubernetes primitives. So the deployment is happening through Kubernetes as opposed to just deploying the WAR file. The clustering is happening through Kubernetes deployment descriptors, which I didn't show you. So let's take a look at that real quick. So here's the Kubernetes deployment descriptor. So there's the deployment. I'm issuing 2 copies of my application. There's the name of the image. Okay. In my local instance, this is actually replaced with the correct values. And you can also specify things like environment variables. That's how I'm connecting to the database. And then there's a cluster IP. This is where the mapping is happening. So we're mapping the 2 instances to a single cluster IP, and the cluster IP is what the Ingress controller is talking to. So there's the Ingress. Okay, and as you can see, there is the setup for the sticky sessions that I needed, and that's why the admin console is working as I would expect. So okay, so going back to what I was saying. So as you can see, basically you're doing the deployment in not doing the deployment of the WAR file anymore, but deploying the application through the Docker images. The clustering and load balancing and certain aspects of the networking is being taken care of by Kubernetes, as opposed to in the app server world that was taken care of by the app server natively. But more or less everything else, all of the concepts in the app servers as Jakarta EE and MicroProfile developer transposes itself relatively well in the Kubernetes environment. So again, this is just the basics of how you get Jakarta EE application running in a Kubernetes cluster. I would invite you to take a look at this repository yourself after the fact and explore a lot more. So take a look at how you do distributed monitoring in a Kubernetes native way. How do you use operators to make the app servers even more Kubernetes native, and also how you can do CI/CD in a Kubernetes-based environment using Jakarta EE and MicroProfile. So thank you very much. I really appreciate your time. I do hope you got something out of our talk today. Hi, folks. So there's a few questions. I'm going to go ahead and answer them in order. Feel free to post more questions. This is your time to basically do those, and I'll just evaluate sort of in my subjective judgment what is a good question that I should answer or not. So the first question I think I'd like to answer is how do you do logging in Kubernetes? So I talked about monitoring and observability, but I didn't really talk about logging per se. The reason I didn't do that is actually it's not that different from how you would do logging in a virtualized environment. The only big difference is the Kubernetes pods are ephemeral. So you really cannot rely on log files stored in the local file system. You got to do some kind of logging outside of the disk in all reality. So something like Elk or Splunk would be a good option. So basically what you would do is you would consolidate all of your logs external to the pods into an Elk instance. The other thing that I have seen done that I don't really recommend is mounting external volumes. So mounting like a shared file system where you basically store all of the log files external to the pod. It's not as effective because it gets a little bit more messy and not as searchable, not nearly as searchable as something as Elk would be. The next question I think is a very good question is how do you secure those environment variables that I kept using in some of my examples. So in my examples, they're basically embedded within the YAML file. And that's not necessarily something you want to do because you don't want to version control those YAML files either. What you want to do instead is actually, especially in a cloud environment, you want to store all those environment variables in some kind of more secure storage, and you want to reference those variables within your YAML file and potentially within your application as well, rather than simply hard coding them into the configuration directly. So one good option is to use Kubernetes secrets. Other than that, platforms like Azure also have essentially in ways of integrating with things like Azure config registry. And basically what they do is they pull those variables from values directly from those secure storage into your environment. So that's another way these things are usually handled in the Kubernetes world. Okay. Next question that looks interesting here is what are some general security guidelines for Kubernetes? So this is a pretty broad question, but I'll try to answer it, if you will, short and sweet. It's not very different from what your virtualized environment typically is. You can consider a Kubernetes cluster sort of as a subnet. So it itself is its own NAT. The only way that it really has an endpoint is if you expose one. So if you expose one via a service or you expose one via an ingress. So if you do expose one, you do have to make sure that that port that you're exposing, either via service or via ingress, is secure. So it's behind some kind of gateway or behind some kind of firewall. And also you have to make a decision of how you want to handle SSL. You can do end-to-end SSL, which is basically making sure everything, all communication, even within your Kubernetes cluster, is SSL encrypted. So you have to set SSL at basically your pod level with the app server itself, just like you would in a virtualized environment. The other alternative is to simply do what's called endpoint SSL, which is basically just whatever your very end endpoint is with the user. Let's say your application gateway beyond your ingress. That's what you want to do SSL encryption. So depending on how much security you want, that's also a good way to go. So I really think that is all the time that we have. I do see there's a few other questions. I don't think I can really answer those questions in a span of a minute or so. But if you have any other short questions, please do me a favor and post those now. Otherwise, I'm always available to chat with you. My contact information is available out there. Easiest thing in the world to do is just shoot me a question on Twitter, and I try to be fairly responsive. So thank you very much. Really appreciate it, and hopefully see you next time in some other virtual or physical conference.